Welcome back to my class. Today and also in our next two classes we will be solving a few problem sums based on factorization. Today we will be factorizing these four algebraic expressions one by one. So let's get started. The first algebraic equation, which is given as you can see here. Now in this algebraic expression we have three terms, and in every term, as we can see, there is a difference of x and y variable. So the first term is a, then it is multiplied by this binomial, and then the second term can be written as it is given y minus x, this binomial. So if we take minus or minus 1 common, then this binomial will be x minus y. Here we will have minus 2b, and then again, as we can see here, we have the square of this binomial or difference x and y. In the other two terms we have arranged in that way, x minus y, so we will keep as it is x minus y whole square, and here we have this monomial c. Now as we can see, in these three terms we have x minus y, this binomial, common. So if we take that binomial common, then from other terms what remains is a. From this term we will have minus 2b, and then from here we will have c. Here we have x minus y square, so one x minus y we have taken common, this binomial, so another x minus y factor it will remain in this term. So c multiplied by x minus y, that will be another factor of this algebraic equation. So if we simplify further, then it will be a minus 2b, then it will be c multiplied by x, so cx minus cy. So this will be the factorization of this algebraic expression. Next we will factorize this algebraic equation. Here in this algebraic equation, in both the terms, what we can see is we have x plus y, this binomial, and also this value 2, this factor, common. So if we take that factor common, 2 multiplied by x plus y, then what remains, what other factors is 2 from here, and then we have another binomial here, 3a minus b, and from here what remains is 3, and then 2b minus 3a. This is very simple. So now what we have to do is we have to simplify further to get the more simplified value. So it will be 6a, then minus 2b, from here it will be 6b, and from here it will be minus 9a. Now we have to simplify a little bit more, so it will be 2x plus y, and then 6a and minus 9a, these two are the like terms, and also minus 2b and 6b, these two are like terms. So we have to simplify 6a minus 3a minus 9a, so it will be minus 3a, and from here we will have 4b. Now if we simplify or rearrange the factors, then it can be written as 4b minus 3a. Otherwise if we leave here only, that will be also correct. Next we will factorize this algebraic expression. Now here we can see it is given in this format, a square plus b square, where a is ax plus by, a itself is, and then bx minus ay is our b. So what we will do is we will first expand this identity, which is again given in this format, a plus b whole square. So it will be a square plus 2ab plus b square, and it is given in this format, a minus b whole square. So if it is minus, then here also we will have one minus, so it will be a square minus 2ab plus b square. This already we know. Now it will be a square, so it will be this time ax then whole square plus 2ab, or maybe we can write plus b square first, so it will be by then whole square, then we can write 2ab. So 2a is ax, b is by. This is from this factor, and from this factor if we expand this identity, then it can be written as bx then whole square. Then I'm writing the square part first, so it will be ay then whole square, and then minus 2ab, so minus 2 then bx then ay. Now if we simplify further, it will be a square x square, then from here it will be b square y square, then from here it will have 2abxy, so it will be 2abxy. Then from the second term we will have b square x square, then from here it will be, we will have a square y square. Then from the third term or last term of this line we will have 2abxy. Now what we can see here, that we have plus 2abxy and another minus 2abxy, so they will cancel each other. And now if we rearrange the terms or like terms, so here from here we have a square x square, and here we have another x square term which is b square x square. So if we combine them or group them, then the remaining terms are b square y square, and then we have a square y square, which are again like terms with respect to y or y square. Now what we can do is we can take x square common, then what binomial factor we will have is a square plus b square in the first term. Then if we take y square common, then in the second term we will have again this binomial term a square plus b square. Now in both the terms we have a square plus b square, this binomial common factors. So in another factor what we will have is, from here we will have x square and from here we will have y square. So this is our simplified answer, the factorized form of this algebraic expression. Next we will simplify or we will factorize this algebraic expression. So if we now further expand this algebraic expression, we will have in the first term as it is aqx, then this from here from the second term we will have a square x, then we will have a square y, then from this term we will have minus ay and then minus az, right? And then from here we will have minus z. Now what we can see is these two are like terms where x is the common variable and along with there is a, and here we have aq, here we have a square. So between these two terms the common highest factor is a square. Between with respect to a, the common factor is, highest common factor is a square, and also x is common. Between these two terms if we evaluate, then we can see this y variable is common, and along with y the a is also common, and the highest common a factor is here a. Here we have a square, here we have a, so common is a. Now between these two terms again z is the common variable. So what we will do is we will group these like terms as per their highest common factor, and we will see how much is the highest common factor. So from here the highest common factor is a square and also x. So what remains in the second in another factor is, from this term we will have a, and from this term we will have only 1. Now if we group these two terms, then what is the highest common factor is, here both are negative terms, so we can take minus 1 common, and then ay is the highest common factor between these two terms. So if we take this common or this as common factor, then what remains in the second factor is, from here we will have only a and ay, if we multiply it becomes a square y, right? So in the second term of this factor of this binomial we will have 1, and then if we group these two terms, then again both the terms as we can see are negative, and the highest common factor here is z. So we will take z common. So in another factor of this term what will remain is a from here for this term, and for this term we will have only 1. So what now we can see is that a plus 1, this binomial is common for all these terms, for all these three terms. So what we will do next is we will take a plus 1, this binomial as common factor, and then what remains in the second factor is, from this term we will have a square x, then from this term we will have a minus ay, and from this term we will have only z. So this is the factorized form of this algebraic expression, and we cannot factorize further. So this is our simplified answer. So this class was about the factorization of algebraic expressions. I hope you have understood clearly what I have solved, what problem I have solved in today's class. In the next class we will be solving a few more problem sums based on factorization. So see you in the next class. Thank you.